morning, everyone. Um, Today, let me teach you a shortcut method, okay, to find the transfer function of a block diagram. Okay, so this shortcut method is quite useful in competitive exam. For example, GATE. All right. So I would advise you to follow this shortcut method only if you are comfortable with the regular, that is the conventional method. Okay, so don't practice this method in your external exam. Okay. Just you can use this method in competitive exams, because in competitive exams, the correct answer is the key over there, right? And nobody evaluates your steps. All right. So this is the given block diagram, and you are supposed to find the transfer function C of s by R of s. Okay. Now, how are we going to do it? Now, over here, while applying this shortcut method, what you have to do is that you have to understand various forward paths as well as various feedback paths. Okay. For example, forward paths. Okay. Forward paths mean, okay, the meaning of forward path means, the movement of the signal from left to right. Okay. Left to right signal flow. Okay, so that is called as forward path. And in addition to forward path, you have feedback path. Right. And what is feedback path? The movement of signal from output side to input side. So that is kind of from right hand side to left hand side. Signal. Okay. So first, these two you need to understand: forward path and feedback path. Okay. The next thing what you have to understand is that the numerator factor and the denominator factor of your transfer function. Okay, in a sense, your transfer function is given by C of s by R of s. Right. So C of s by R of s will have some numerator factor N of s and some denominator factor D of s. Okay. Now remember one thing, your N of s, okay, that is the numerator factor, is consisting of forward path gains, right? N of s is consisting of forward path gains, and D of s is consisting of feedback path gains. Okay, feedback path gains. So all what you have to do is identify the forward path gains and identify the feedback path gains. Okay, using inspection method. Okay, now let me tell you how are you going to identify the forward path gains. Okay, say for example, if you inspect, let me choose a different color, the forward path. Okay, what did I say in the beginning? Forward path is nothing but the path in which the signal flows from left hand side to right hand side. Okay, so these are the elements of forward path. Okay, so pink color I have used to identify the forward path elements, and feedback path, of course, for feedback path you are going to have the forward path element as well as the feedback factors. So that we will do consider a little later. Okay, now we can directly write down. Okay, this problem I think we have already solved in the class, so later you can cross check the answers. Okay, say for example, over here itself, let me write the answer. Okay, now you see G2 and G3. This G2 and G3, don't worry about the takeoff point, okay? Because takeoff point we are going to shift in our regular block diagram reduction technique, right? So over here, we are not going to apply the regular block diagram reduction technique. Instead, we try to write the answer using inspection method. Okay, so over here, what you can see is that G2 and G3, they are kind of connected in cascade, okay, with the exception that there is takeoff point from them. Okay, just ignore that takeoff point, because this takeoff point we will consider while identifying the feedback path. Okay, so G2 and G3, they are connected in cascade, so you can directly write G2 into G3. Okay, now this G2 into G3, so this is in cascade, all right, and this cascade connection comes in parallel with G4. So what happens? The overall transfer function okay, that is this. The overall transfer function of these three blocks is basically G2 into G3 plus G4. Okay, so directly you can write it down here. G2 into G3 plus G4, close the bracket. And this overall transfer function comes in cascade with G1. So what do you mean by cascade connection? The multiplication of two block transfer functions, right? So G2 plus G3 into G4 into G1. As simple as that. So this is your forward path gain. Okay, this you can cross check with your what you say your class problem. Okay, so that is your forward path gain. And now let us try to find out the feedback path gain. So let me write here. Okay, now as you can see that in this given problem, okay, the feedback is negative in nature, right? It's a negative feedback in nature. So quite obvious that, okay, the feedback path gain you will get in this form, 1 plus g of s into h of s. Okay, all what we have to do is we have to identify various g of s and h of s factors. Okay, so firstly let us write 1 here, okay, 1 plus, okay, and then you start collecting here I will write start collecting various g of s into h of s factors. Okay, fine. Now if you inspect closely, okay, I will mark in this no, I'll use this green color to identify the various feedback loop. So over here you can see one feedback loop. Is this visible? I don't think so. It is visible. Let me use the highlighter pen. This is my feedback loop. This is my feedback loop. And what will be the feedback factor? Here G is G2, G3. Okay, G is G2, G3 and H is H2. So I can directly write 1 plus G2 into G3 G2, G3 into H2 plus we will identify the other factors as well. Okay. Next, what we have is this path. Okay. Carefully, you have to observe. I'll use a different color. See, this is also a feedback path, right? G4 and this H2. Okay, G4 and H2. This is also a feedback path. All what you have to do is you have to just follow the color coding. Okay, so I can directly write down the answer as G4 into H2 plus. Okay, next I have the feedback path somewhere over here. G1, G2, H1. Okay, so that's my third feedback path. Okay, then I have my fourth feedback path. Okay, red color will use. So that is this one, the outer loop, outer loop. So that's straight path. This one, the outer loop. So in the outer loop, what is H? H is unity, right? So your feedback gain is G1 into G2 into G3 into 1. So it is G1, G2, G3 plus. Then finally, I have my, what do you say, the fourth feedback that is somewhere over here. Yeah, this color will use. Okay, this one. Okay, this one. G4, the upper part. Okay, because this point is getting connected here, no? And this unity path. This unity path. So what is the transfer function? G4 into, okay, yeah, you have to complete this one. So look at this, the top path. Okay, it is basically G1 into G4 into 1. So G1 into G4, that is the forward path gain into the feedback path gain, which is 1. Okay, so there you are. So that's your transfer function. Okay, so we can write now C of S by R of S is equal to, the numerator factor already we have written, right? So that is G2, G3 plus G4 into G1, okay, divided by the denominator factor, which is nothing but feedback path gain, which we have already written over here. So that's 1 plus, all right, just copy this. This is your answer. Okay, so I would request you to check this particular answer with the conventional method. Okay, using conventional method, we have already solved this particular problem. All right, so that's it for the day. You can try out this shortcut method with problems as well. Okay, and do share your feedback with me. Okay, thank you.